Hello everyone, my name is Vaibhav Jain. I am a specialist solution architect at Red Hat. Today I want to demonstrate the developer friendly capabilities inside the OpenShift container platform. I'm sure you must have interacted in the past and you probably already know about certain capabilities, but let me extend today's demo to some of the advanced capabilities which does exist inside the OpenShift container platform. The idea is that using those capabilities, developers need not to really learn much about the containers or the OpenShift container platform. The idea is that they focus more on developing their applications, but then the part where they have to deploy and manage some of the application should be very easy. So for today's demo, I'm going to use Quarkus Superheroes Workshop. If you already haven't heard about Quarkus is one of the very lightweight, one of the very fastest framework which now is part of the Red Hat OpenShift container platform, and we really recommend to have a look at it, to leverage it for building your microservices applications. There are many benefits what you get when you actually start using Quarkus, and let me in fact demonstrate you some of them. So as you may know that this Quarkus Superheroes Workshop is more focused on understanding how the Quarkus work, how to develop code around it, which is very similar to if you are probably a Spring Boot developer or if you are a Java developer. But the idea is that we offload many of the capability, many of the challenges, concerns from a application development point of view at the runtime at the platform layer, which becomes more like a configuration available to the developers. They simply configure it, you leverage it for the more effectiveness of your application from a management, deployment, scaling point of view, high availability point of view, and so on. There is a GitHub available for the Quarkus workshop. What I have done, I have made a copy of that particular source code into my own repository, which is this repository as you can see over here. What I'm going to do today is I'm going to deploy all these microservices where there is a hero, there is a villain, and the fight happens within them and someone wins and the result goes into the database. At the same time, result also is being pushed to the Kafka, which again we're going to deploy on top of Red Hat OpenShift container platform, and in a reactive fashion, statistics application which works on the WebSocket based scenario, and there is a UI through which we actually see how many fights have been happening, who has been winning, and how do we interact with this application. For that there is a front end which is built on AngularJS packaged along with Quarkus, which again we're going to deploy on top of this. So this is the whole intent for the today's demo, and as I said, we will be looking at some of the functionalities like health checks, like monitoring data which is being exposed by Prometheus. Now let's get started. All the steps which are required to reproduce this lab are very well written and given up on this GitHub itself. So you can go and have a look at the README file to kind of now actually show you this live. Let me start copy pasting some of this thing, and then we're gonna follow this into our demo now. So I am into a directory which is kind of blank right now. So let me first make a copy of the source code over here. Okay, we have the source code now, so let's go into the directory. Let's have a quick look at it. So we have all the microservices as I spoke earlier in this particular directory. So first thing first, as the upstream Quarkus workshop says, we need to install the extension over here. So let me just paste the command over here quickly. This sets up some prerequisite from compiling those microservices point of view. So let's just check that I am logged into the cluster. Yes, I am already logged into my OpenShift cluster. So let's go and create one directory now. Sorry, new project inside the OpenShift container platform. If I just want to check again one more time, so we are at the superheroes app which we just created. So the first step towards building this application is to create these databases and then deploy these microservices. So we're going to start with the villain microservice, where we're going to deploy the PostgreSQL first and then the application. So again, commands are given up on the Git repository. So let me copy and let me paste it over here. We deploy this and you can see that the database is now running. Okay, so the next step is basically we need to deploy the application. Now these are some of the extensions what I have done into the upstream application. How did I do that? Is basically I enabled this Quarkus extension, which is this, which can be inserted into your pom.xml. This dependency gets added, and what it basically does is that now using your maven command itself, you can actually deploy this application onto the OpenShift cluster. So this is one of the command which I had already run in my pom.xml. So if you go and check, you will find this reference. But if you are trying to deploy this into some other application, you can actually run the same command, and then from there itself you go and deploy the application. No need to interact with OpenShift in any fashion. The another addition what I have done is I have enabled the Prometheus matrices, this micrometer registry add-on. Again, this dependency in the pom.xml, you can go and very well see this. What happens because we enable this is we get metrics for all of our microservices, which we can use to scrape the data from Prometheus to actually understand at the business level how my applications are behaving. While this by default gives you lot much data, this can be further expanded into business level transactions as well. So where I can actually say, how many fights have happened, give me those number of fights, how much time every fight took, and so on. So we can actually get that kind of data as well. So coming back, let's go to the source code repository. I'll just paste it over here, and then I just run this command, and let me take a moment to actually explain this. So we are doing a clean package, and then I'm saying deploy this on OpenShift, where it is going to get deployed into the current project, into the current namespace, and we are already into the right namespace. We checked it. I'm going to skip some maven tests just to reduce the time, because as a part of my development exercise while we were doing this in the earlier workshop, I have already done it, so I'm pretty much sure it's going to work. and then I'm setting up certain ports just to kind of demonstrate that there are some additional capabilities, like when you actually go and have a look at this, you find that there is a whole list of parameters which are available, which can be kind of used from a deployment point of view. The good part is that it automatically configures things for you inside OpenShift. You simply keep them as a part of your either application.properties, or you can pass them on as a parameter to your terminal. Since this application is going to be running on 8084, so let me quickly run this. As you can see that it has already started interacting with my OpenShift cluster. It applied image stream, it applied image stream for my application, other one was for the base container image, which it automatically identified based on the source code and the pom.xml. And then it is now configuring a build configuration. So basically what it is doing, it is compiling all my code and pushing that code as a binary to one of the base container image. It's gonna take a moment, so let's wait for that to happen. While this is happening, let's go and check inside the OpenShift terminal as well. There are two consoles what it provides. One is the administrator console, the other one is the developer perspective. So here are we at the developer perspective. I can go and simply choose my project, which is superheroes app, and you can see over here, right, there is a villains DB because we created one database, so it is running up over there. If I click here, I get to see more details, how many replicas, what is the pod. I go and actually have a look from all that point of view, but I'm waiting for the application to come up. It's gonna take some time, so we might have to wait for a minute. Fast forward, and we see the application has been built, it has been pushed into the internal registry, there is a deployment config which has been set, and if I go and have a look at my console, I see one application coming up over here, right? Good. Now how do we access this application? So let me click on this, and as you can see, there are ports which we had defined are coming up as a service over here. But how do we now expose this to access this application? Well, there are two ways. One is I can go and run this command which can automatically create a service for me. But let me show you from the UI. So I click on routes, I go and create a route, I give this a name, okay, I choose the service from here, I choose the port, and I say yeah, it could be secured, let it be terminated edge, and I want insecure traffic to also get allowed, which means now basically HTTP and HTTPS, both the traffics are allowed. So I simply scroll it up, scroll it down, and I say create. Here is my route. I click on this, and here I can see my application available. Now you see over here there is a API endpoint. So let me click on this, and you see all the data which is now actually coming from the database. So now it gives me some relief that my application is now deployed and working perfectly fine. Okay, if I go back to the topology, you see there is a icon over here, open URL. So if I actually click, it can again open it, or I can scroll it down, and here also I can see my now newly created route. Okay, so next step, we go and deploy another application. The other application is the REST Heroes application. So again, first thing is we need to deploy the database. So let me come back here, clear the screen, I paste this command, and if I go back and check, I see another hero database, right? Now you see these icons coming up, right? These are just for the visual reference point of view, just to understand, you know, which application is talking to which particular component, because we're gonna be building up multiple, so probably it can be helpful to understand. Okay, so we have this. Now let's move on to the sorry, I need to first go up, and then I need to come here, and then we run the same command again, but this time this particular service is running on 8083 port. Okay, so quick question, how do we understand where it is running? How do we identify that? In order to do that, what you can do is, if you import your code into your, you know, in your choice of editor, and you go and look at let's say these services, under the SRC main resources, there is this application properties, which basically defines these ports. Why we are having these different ports? The reason behind these ports, because if we're going to run them all together, all these microservices on our local laptop, which was part of the actual original exercise, right? We don't want services to get in a conflicting mode, so that's why every service is using a different port. And I could actually change them, but I thought to kind of follow the same, you know, as close to as what the upstream code is there, right? So this is the reason why we are following 8083. Okay, let's copy this command, let's paste it over here, and again it's gonna take maybe 2 odd minutes. Okay, so now the application is successfully built and deployed. You can see deployment config, this thing. If I go back and check my application over here, you see REST heroes now is coming up. Again, let me just do a visual connector over here. All right, and again we see there is no route over here. So how do we do that? Is let me use this command line this time just to kind of quickly show you. Okay, let me clear the screen, and I pasted this command and it creates a route for me. I can see OC get route, and okay, my bad. This was supposed to be REST heroes. So let me actually correct this REST heroes, and let me do this again one more time, and you see this URL now which is on 8083. Let me copy this, go back here, http:// and hit, and again you can see this. Now if you basically try to copy and paste the URL just like this and you hit the enter, it might actually take you to HTTPS as well. And if you actually see this URL is not enabled for HTTPS, so you might get to see this application is not available. Do not worry, it is just that you need to correct the URL, that's all. Okay, so again I see API heroes over here and I see all the data coming in, so fantastic. We have now 2 applications deployed so far, and our hero and villain is deployed. Now the next component is the fight, right? But before we go and deploy the fight component, we require Kafka, okay, and we also require database. So let us first complete the database and then I'll show you how to deploy the Kafka. So let me just copy this command again and clear the screen and deploy this one more time. And my fights DB is now deployed. Okay, so let's go to the fights directory because that's where our code is there, and we're gonna be deploying the code. But here I'm doing it little bit different. So far we have been directly deploying the code, but this time I want to deploy the code but not actually want to run the container. So how do I do that? Instead of this parameter of deploy, this time I'm using only the build. So what it's gonna do is it's gonna only build my application as a container inside the OpenShift container platform, but it is actually not gonna deploy. And on the project screen you will not see any container coming up. So there is no deployment config created by this command. Okay, so as you can see that my build is push is successful, but you don't see any deployment confirmation coming up over here. And if I go and see over here, there is fight database, but there is no fight microservice. There are benefits for this particular approach, as you will be probably building your applications multiple times. You want prerequisites to be available and so on, but you want to kind of make sure that your image is there. Now, if I want to deploy version 2 tomorrow, I simply run this command again and my deployment can automatically get, updated. Okay, that's the benefit of this thing. Coming back to the steps, now in order to deploy my application, what I need to do is I need to deploy AMQ streams operator, which is the Kafka, and then I need to create a Kafka configuration, a Kafka broker, and one Kafka topic. So now we're going to use the user interface. Now for deploying the operator, this is something which administrator has to do it for you. If you have the rights, fantastic. If you don't have the rights, probably you need to ask the administrator to enable this for you. The idea is that if I need Kafka, I should not be wasting my time and energy to deploy and managing the Kafka. That's where the operator comes into the picture. So let's go and see this AMQ streams, and this operator can do many things for me. So let me quickly go and install this. I say I want to run this only for particular project inside my multi-tenant OpenShift container platform. I go and install this. We have the operator installed now, so let's go and click on this installed operator. Make sure that you are into this superheroes app namespace. Let's go and click on this. Now this is the interface through which we can deploy our Kafka cluster inside OpenShift, and it can automatically deploy all the instances of Zookeeper and so on for us. So let me go and quickly click on Kafka, create Kafka, and I can click on form view, and here I define the Kafka cluster name which I want for my application. So I'm going to use superheroes. Sorry about that. Superheroes dash Kafka. Again, this is the name which has been defined inside the application.properties. So in case if you are planning to change this, please make sure that your code is also updated. I don't need to change anything because I think I'm going to go with the remaining stuff like these are the ports, this is going to be an ephemeral thing, and I'm going to use 3 replicas, and there is a Zookeeper and so on, but I don't intend to change anything for the demo purpose. So I simply go and click on the create. Now you see within 2 minutes you will have the whole Kafka cluster deployed on top of OpenShift. That's easy how it is to actually deploy Kafka with the help of AMQ streams operator on top of OpenShift. Okay, now we can see that it is in ready condition, which means my cluster is available. I go now and create one Kafka topic. I click from here and I define the, let's go to the YAML view this time, okay, and let's change it from the YAML view. So I want to change my cluster name to the one which we had earlier created, which is superheroes dash Kafka, and topic name is gonna be fights. Okay, since for the demo purpose I intend to run only one consumer, one producer, so I'm gonna change this to one partition and one replica, and let's go and create this. And here you go, you have a fights topic now. If I go back to my developer console, I see that a whole Kafka cluster has come up over here. You can see that this is my Heroes Kafka broker, this is my operator, and this is my Zookeeper, right? and if I click any of them, you can see they are running in 3 replicas, so high availability is out of the box. Okay, so now I have my Kafka, I have my other 2 services, so let's go and deploy. Okay, how do we do that? We just completed all these steps. Now we completed till here now, and now we need to follow these steps, where basically we go and try to deploy one application which is already now available inside the registry. So let's click on add. This is another way to deploy the application, and I go to my container images. So if you have already a built-in or somewhere else a container image available, you simply go and deploy this. I choose it from here, and then I choose it from files. I choose the tag. This was the version which I had chosen. So let me change it to the Quarkus application. For the time being, I am saying, let's say, no application group, but you can create one if you want. I choose the REST files. I leave it at deployment on the port. Again, here we need to choose the port 8082. Again, you can go and look that into REST files. Let's go and see src main resources and application.properties, and here you see 8082 port. So that's where it is important to define 8082 port, and I leave it like this, and then in secure traffic I say allow. That's all, and I go and say this thing, and you see there is one application REST files coming up. Okay, it's already up. I go and click over here. Okay, fantastic. I click on this, and I see, yeah, and I see API files. You see no data because we haven't been able to do any fights yet, right? But there is another random fighters URL which you can actually see, and you can see some data coming up. Now it kind of ensures that, yeah, my service is working fine. So let me close all these tabs. Let's move on. Okay, another important thing. So if I go back to this URL, you remember I was talking about this metrics endpoint, and inside this workshop there is also a section around the health, which is basically can be used for detecting your application readiness point of view. So these are the URLs which can be actually also checked. So let me click on /q/health. I can simply append that over here, and I see the data, right? So it says that, yeah, reactive messaging is okay, REST endpoint is okay, database is connected, my reactive messaging is again connected, and startup is again connected. So startup readiness, everything is working fine, right? If I want individually to check them, oops, my bad, I need to open that again. So what I'm saying, if I need to check individually, I can actually go and have these further URLs appended to it. So it tells me whether my application is live. Now these can be hooked to your health checks, which actually are part of your deployment strategy. So here you can say add health check, and here you can define that this is my readiness probe, this is my liveness probe, this is my startup probe, and then OpenShift can understand, and if your application is not coming up, it will not send the traffic, and it can try to restart, and it can do all that thing, right? There is another one which is this Q Health UI. I am not sure if this is going to work, but let's try if it can be. Okay, yeah, it's not there. It can be there in the dev mode. The other one is which I wanted to highlight is this metrics one. So what does this metrics do? Metrics provide all the monitoring data for your application. This monitoring data is coming from that extension. You don't have to do any coding in your application to get this basic data, but on top of it, yes, you can actually extend this and you can configure it as per your requirement. So you can see over here there is a lot of Kafka related stuff, right? Performance, which version, how many in-flight messages, what was the time, how's my application behaving, this is my JVM related heap size and so on. all that related data is available, so you can now create different type of charts just to understand your application is working as per your performance and the SLA requirements. Pretty good thing, and this is something which Quarkus gives you out of the box. Another benefit of using Quarkus. Fantastic. So now we have all the backend components. Let's now go and deploy the front end component. So for that we need to go and go to my event statistics. Let me clear the screen and I come here, event statistics, and then this time I am gonna deploy directly. But this time my port is 8085. Again, if you are interested to know more, go and read the application.properties. And here you go, application is deployed. I go back and quickly see, yes, this is my event statistics. Now this is running. Again, there is no route over here, so let me go and create the route. Okay, and you see URL coming up over here, so let me click on this and you see the super stats application is running. So I'm gonna leave this open, okay, because we're gonna probably use it at once we're gonna start the fighting, right? Now how do we deploy the main application, which is the fight, right? Now that's based on AngularJS, right? So what I need to do is I wanted to demonstrate is another way of deploying the application, this time using the Docker strategy. So I go back here, I click on this add, I come back to my import from Git. This is the S2I methodology. Okay. Now, what's the URL? This is the URL, right? So I pasted over here. Git reference is master branch. It's not main, so you have to mention it. The context directory is UI-superheroes. And the moment I type this, it automatically identifies that there are multiple import method strategies which are available, and the preferred one here is the Docker file, because I have a Docker file in that particular folder which actually defines that how do I want to build my application. So again, for application grouping, I'm just gonna say no application grouping, and I'm gonna change the name to UI superheroes. I'm going to leave the deployment, and port is 8080, but I need to type it over here just to make sure that it really catches it up, and I expand, and here I say allow, okay, because I want both type of traffic, HTTP and HTTPS. The reason I'm allowing HTTP traffic, probably you don't want to do that into your production environment, but for the demo I'm doing it because of the cross origin resource sharing, which probably can't work on the HTTPS or the secure traffic. So that's the reason I'm allowing it, so that my application works perfectly okay. Okay, so I go and deploy this, and you can see there is a superhero coming up and there is a build running. So if I go and click on this, it actually now building the container inside the OpenShift container platform. So far we have been doing this as a part of the Maven on a local machine, but now it is happening in a different fashion. So the build is happening. This is part of the source to image strategy, and you can see that in a few moments container will be built. So as you can see, this server side build where the build was happening inside a container within OpenShift is now completed because the image has been pushed into the internal registry. So if I go back and check onto my topology page, now you see that this application is coming up, and there is already a URL created because I used the UI this time and we had given the option. So if I click over here, the application is expected not to run. Why so? Now the reason is that in a typical production scenario, you don't want to expose different routes or the URLs to the end user. They will simply have, let's say, abc.com or xyz.com. What we have been following, if you have been carefully looking at, all these routes had different naming conventions. But since this is going to be my main UI, I don't want to tell my end users to have different paths. But in order for browser to understand, it requires access to the Fight API data. So if I really go and have a look at my developers tool, you can see that it is actually missing all that, there are errors because it is not able to fetch this /API/fights, and it is looking at this URL. So how do I fix this? This is a typical requirement in a production scenario where you probably want to do lots of virtual hosting. So how do we do that in case of OpenShift? OpenShift has got a HA proxy router through which actually all the traffic comes, and we can tell our HA proxy router that for this URL, while the URL may look same, please send the traffic to somewhere else. So now what we're going to do is we're going to send our API data, fights data to the fight services, right? For that, first of all, let me just make a copy of this UI superheroes URL, because that's the URL which is being used by the browser or the AngularJS UI. So I'm going to now create a new URL and I'm going to call it as UI fights APIs, and I'm going to paste the host name. Remember to remove this URL because it expects only the string, and here under the path, because the slash is already somewhere else, here I want to simply send only the /API data. I put only the /API. I choose the service to which I want to send the data. I am saying that I want to send this data to REST fights. On which port? I want to send this to 8082. And again, do you want to keep it secure or not? I think let's keep it both, because if you are actually using UI through HTTPS, it might send the traffic to this data on HTTPS. If you are using HTTP, it might send it to HTTP. So it's better to have both configurations. And I go and click create over here. And as you can see that this URL has been now accepted. So if I go back here and refresh my UI, and you see some more icons coming up over here, which means that now my application has started working. Okay, these images of heroes and villains, sometimes they may not work because of the backend data. So try this couple of times until you find it satisfactory. And okay, I get both the images and now I want to make them fight. Do I want to know more? Yes, there is more information coming up over here again from the database, but let me click and make them fight. So I have my first fight, and who wins? Syndragosa wins, right? Okay, let's go back and check onto our the statistics application. There is no data yet. Okay, so it generally takes 2 to 3 hits. And we have one more. Let's make them fight one more time, and this time Domino wins. Okay, let's try few more times. Okay, and Yellow Jacket wins. Okay, so we have 3. Let's go back and see. Still we don't have it much. Probably we need to give it more time. But what we can do, we can keep them fighting. So I click one more time, and you see another Yellow Jacket. Another time Yellow Jacket has won. I do it one more time, and you see third time he has won. Why I am doing so? Because when the data will come, it will actually show it up over here. Okay, let me actually refresh this one more time, and then let's try some of the new fights. And Machine Man wins. I did it one more time. Another time Machine Man wins, and yeah, Hulk wins. One more time Hulk wins, another time Hulk wins, and here you see, right, heroes are winning and villains are losing. and this is the data which I wanted to show. So that's all from my side today. If you're interested to know more, I'll highly recommend you go and read this Quarkus Superheroes application. It tells you many things in detail. You can run it on your local machine with the help of Docker, and looking forward to see you in the next demo, where I intend to present more around the matrix Prometheus data which we expose through this application. So how we're going to make use of it, that's what the next demo is going to be about. Thank you so much for attending today's demo. Have a great day.